Look, projectile motion is also called motion in plane. In plane, or you can say two-dimensional motion. Why we say this as two-dimensional motion? Because if you throw any object from ground making angle theta with horizontal, so it travels a path something like this, isn't that? So that means it goes up as well as is going horizontal distance. So at the same time, two dimension, because going in a vertical plane, isn't that? It goes up, comes down at any point of time. It has x and y coordinate, both are there, every time it is changing. So that is why we call it projectile motion or motion in two dimension, because there is a two dimension motion. Now the basic principle about this is this will follow the motion equation of motion. What are the three equation of motion? We have three equation of motion are s is equal to ut plus half at square, and v is equal to u plus at, and v square minus u square is equal to 2s. And we'll solve this by using one dimension motion. Okay, means what we'll do, this consists of two one dimensional motion. Why? If let's say if this velocity is u, you have thrown this with initial velocity u, so can I say the horizontal component of u is u cos theta and vertical component as u sin theta? Fine. So can I say, if I write u in vector form, can I say u cos theta I plus u sin theta j? If I say horizontal as I and vertical as j. Okay. Now can I also say acceleration is in downward direction, and here acceleration is in horizontal direction, is 0. So acceleration, vector component acceleration, can be said that 0 I, because no horizontal acceleration, minus g j. Why minus? Why I'm doing minus? Here is a plus. Yes, upward is positive and downward I have taken as negative. So this is in downward direction. Very good. Excellent. Now if I have to find out motion, we'll try to find out the equation of this motion. Equation means what is the equation of the motion, means the path followed by it. That is one thing we'll follow, and also we'll try to find out the range. Range is the first time it dropped at the same level of the ground, and also we try to find out the time of flight, the time taken to reach here, and we'll try to find out the maximum height. But first we'll try to find out the equation of the motion. Okay, so let's say I just reduce this. Okay, so we'll take horizontal motion and vertical motion. For equation of motion or motion of path of projectile. Okay, so if I find the equation, we can find out every point where it is, so it is more easier to find out, isn't that? So displacement at any point time, any time t, let's say displace at any time t, it is at xy. So s can be written as xi plus yj. Fine. Now considering horizontal motion. if I consider horizontal motion, what will happen? Horizontal motion, all the x components, no? So displacement is, in x direction, displacement is small x. Time taken is t. Time is t for both horizontal and vertical. Fine. And then acceleration is 0. Okay, in x direction there is no acceleration. And initial velocity is u in x direction is u cos theta, we find out, isn't that? So we'll use formula s is equal to ut plus half at square is the formula. So x initial velocity is u cos theta into t plus half into 0 into t square. So from here we get t is equal to x by u cos theta. One thing?
Yes, sir.
Till here is fine.
Yes, sir.
Now we'll consider vertical motion. Considering vertical motion. So in vertical motion, your initial velocity uy is u sin theta. Displacement sy is y. Time taken, time is t, which we have already found in equation 1. So we'll use this value, which is x by u cos theta. Fine. And acceleration is minus g. A in y direction is minus g. Okay, we have already written that. So now here we'll use the formula displacement s is equal to ut plus half at square. So s is y, initial velocity is u sin theta into t is x by u cos theta plus half minus g into t is x by u cos theta square. So it gives you y is equal to x tan theta minus g x square by 2 u square cos square theta. Okay, this is y. Fine. This is the equation. Can I say this is the equation? So
Yes, sir. Yes.
from here you can say this equation is a parabolic equation. This is an x square form. So parabola. So path will be parabolic path, and you can see the path is like this. Now,
Yes.
now if I want to find out the range, okay, and the time period and everything, so how will we find out from here? Okay, so I'll just so to find out a range. So range is, if I make the figure, again I'm making the figure. So at range here, if this is 0 0 and this distance is if r, so this is r0. So at range, at this point, x is r and y is 0. Now you put this value in equation, let's say this equation 2. Okay, so if I put this value y is equal to 0, r tan theta minus g r square by 2 u square cos square theta. So I'll take this one this side, so it will be g r square 2 u square cos square theta is equal to r tan theta. Okay,
Yes, sir.
or instead of tan theta, can I write sin theta by cos theta?
Yes, sir. We will write.
So 1 r can be cut, and 1 cos theta cut. So you can say r is equal to 2 u square sin theta cos theta by g, and 2 sin theta cos theta can be written as sin 2 theta. So u square sin 2 theta by g. So this is the formula. So if you know the equation, you can find out this is a special case of that equation when it reaches at the same level, isn't that? Nothing else.
Yes.
Fine. Second thing, if I have to find out maximum height, so at maximum height, we also find out maximum height. So when it is at maximum height, this is by symmetry, you can say this is r by 2. So at maximum height, we can say at maximum height, this one x coordinate is r by 2, x is r by 2, and this is h. I can say like this. Okay, so this is one way, or other way you can use the equation, vertical equation. That's the other way. So
Yes, sir.
so this is range you find out. Over here. So next thing is to find out time of flight. Time of flight. Time of flight. So time of flight. So if you see the equation, a time of flight t, time of flight, for the time of flight, if this is the thing, if it reaches here, the time taken to reach here, isn't that? So in that case, your formula is t is equal to x by u cos theta, isn't that? So x here is
Yes.
x at this point. So if I put t, x is r, isn't that? This distance is r. So I put r by u cos theta. R, just got the formula, r is u square sine u square sine 2 theta by g into u cos theta. So can I write u square sine 2 theta can be written as 2 sine theta into cos theta by g u cos theta. So cos theta cut. So can I say time of flight is equal to 2u sine theta by g. So this is also we can find out by the equation. So base thing is equation. If you know the equation, you can find out everything else.
Yes, sir.
Next thing is, if I'm trying to find out maximum height, maximum height reach, maximum height reached. Okay, so for maximum height, okay, so this was u and this was u cos theta and u sin theta, the component of this one, and g was there in downward direction. So we take if I take vertical motion, taking vertical motion, so uy is u sin theta. So upward I am taking positive, so downward acceleration is in downward direction, so I take minus g. So displacement is h, maximum height reach is h. So at this will not go further, because at this point of time this velocity uy or vy is become 0. This component is there, ux will be there with something. Okay, so that is why it will go this way, and due to acceleration it will come down. So at this point of time final velocity is Vy can be said as 0. So we'll use formula v square minus u square is equal to 2as. So 0 square minus u sine theta square is equal to 2 minus g into s is maximum height. So can I say h is equal to minus u square sine square theta by minus 2g. This will cut. So therefore you can say h is equal to u square sine square theta by 2g. So this is your formula for the equation. Hope you understand till here.